So, for first part of this session, topic is called software process models, and I will try to tell you what is general patterns or meta models or models of models, which are similarities between different kind of software development methodologies, frameworks, or models or whatever. And so I will try to explain you what are different kind of similarities and differences between different approaches of management of software development projects and IT projects in general. So I will briefly go through different approaches like waterfall model, V model, incremental delivery, spiral, and unified process. And I will explain in more details what are general concepts used for these methodologies. And what is very important for information technologies in difference with other technologies is that in general software is tangible if you think that bits are tangible. If not, then of course these bits are just information encoded in tangible things like compact disks, SSD disks, magnetic disks, etc. But what these bits represent in general is information or knowledge about something, how something should be going on, etc. So in general, when you develop software, when you maintain it, etc., you are doing information management, and only difference is how exactly you encode this information in different kind of programming languages, tools, etc. And therefore, in general, software development is knowledge management, how you manage your knowledge and how you put this knowledge somewhere, how you store and reuse it, etc. And that's why, one of reasons why, for example, when we will talk in details about licensing and legal things, software development is very related with a thing called intellectual property, because influence of intellect, influence of information is very important during software development process. And because of that, all of these approaches, frameworks or models deal with different kind of information related things. For example, they describe what should be happening, what should be outcome, what should be preconditions, postconditions, etc. Who does something, who is responsible for something, etc. Why something is happening, what is reasons for these particular tasks, activities, or whatever. What are smaller steps, how exactly it should be happening, and how to check quality, how to ensure that this process is going right, that it is not going wrong, etc. And all of these things in general are about information. You try to encode and store and get different kind of answers to different kind of questions, and then you use information collected, gathered during this process as these answers to do something in the project. And depending on what kind of ideology, methodology, school of thought are you using, different things may be called differently and similar things may be called differently, but in general we talk about different kind of models, and model may be also called like a framework. And you should know already what framework is for programming languages. Framework for programming languages is set of libraries together with information, no big surprise, how to use these libraries properly. And regarding to software development and management of the projects, so these frameworks are information and tools for management and other activities, and then some information how to use them properly, how to ask right questions, how to get right answers, and how to use these answers to continue your activities, your work in particular project. And then, because all this is related to information or knowledge, and of course if you go in more details about what is information theory and knowledge, so lower level is just different kind of data, hopefully structured data, then you can get some information out of these data, and then knowledge is some kind of wisdom on top of information, which allows you to decide what you should do or what you shouldn't do regarding to this information somehow encoded into data. But because this is in general information handling, in many cases we deal with different kind of documents and documentation describing what current situation is, prescribing what you should do forward, and other things. So, and we will go in more details later. You may try to write different kind of specifications, designs. You may work on validation and related things to check that your progress is good, etc. And then you do different kind of evolutions or changes during this project, because there is nothing more permanent than changes. And in general, what are important concepts for all these frameworks and models is, for example, what is names for the different kind of behavior, how you do things, what are names for different kind of output. So in general, product is something what you produce. If you are working in engineering and construction and building, product is like a ship, car, house, etc. If you are working on IT, your product is different kind of software with some name for it. And you may not be product oriented. Many of companies today are product oriented, but more and more companies become service oriented, so their main kernel of these activities is not producing something, but main kernel of these activities is serving something. Then you may see different kind of roles or different kind of responsibilities, what different kind of people should do. Then there may be different kind of pre and post conditions, like quality checks and statements or conditions which need to be fulfilled before you finish some of these activities and start new one. And in general, when we will go into different kind of models, if you look on real life, development of software, maintaining it and other thing is very complicated and messy. Even for small and trivial projects, there may be many different activities going on, etc. But to see some similarities and differences, there may be these different kind of frameworks or models which distills this most important information and knowledge on this messy everyday life to use as a guideline, as a framework, to understand what is going on, where you should pay your attention, etc. So what is process framework here? Maybe also called like model of these activities, like V model or waterfall model or whatever. And then there are different kind of large activities. So this process may be called project, this framework may be called model as well. But of course, if you apply different kind of models in real life, you will see that you ignore some parts of reality depending on which kind of model you are using, because models are always much simpler than reality, and that means you ignore some things. Hopefully these can be ignored and you pay attention only to important stuff, otherwise it's just too complicated to manage and to understand. And then smaller parts, in many kinds of situations, these may be going concurrently in parallel in separate threads of activities, are things called activities. And then inside these activities are different kind of tasks, and task usually is the smallest unit which you are using to manage these projects. Usually you do not split task in something smaller. There may be tasks containing other tasks, so some task can be container for other task, but usually task is smallest unit of manageable things in different kind of methodologies. And then there are these kind of generic process models or meta models which describes similarities of many different approaches of these methodologies. And in this generic process model, you see on generic or recurring patterns in any kind of project you are working on. And what may be these different kind of generic things? First, and by the way, pattern in proper Latvian is called, I think, raksts. So you see different kind of patterns, or dažādi raksti, inside these messy activities, and these recurring patterns are following. So one of patterns may be linear process follow. You split this project's activities into smaller items, maybe in other sub-activities and tasks and sub-tasks, etc. But you go through them linearly. You start with something, you go to next activity or task only when previous one is finished. Other thing is you do different kind of iterations in different kind of levels. Like instead of going only forward, never looking back, you may review it and then you can reiterate either through smaller loops or larger loops. For example, you may reiterate one particular activity called modeling, for example, communication and planning, and then you reiterate it in larger loops, so something like spiral into spiral. Then there may be spirals which do not contain other spirals into them, like in other methodologies you do not have sub-iterations for a particular task, but your approach, how you review things and maybe redo things, is always in the same pattern, like communication, planning, modeling, instruction, deployment, and then again. And then there may be different kind of mix for these. For example, instead of absolutely linear thing, you do something concurrently in parallel. And these are just patterns, what you can see in different kind of methodologies, but you will always see them. And of course, in real life, there may be a bit of everything of them here, but if you will always go into all possible details of real life, then of course life will be too complicated for you to handle it and understand it properly. And so these are different kind of reoccurring patterns you may see in different kind of methodologies. And in real life what happens is that usually you do not follow only one pattern, but you may use different kind of patterns depending on different kind of situations. And then you sooner or later need to divide and conquer. You need to split larger activities into smaller activities and tasks and even smaller tasks. So you need to understand how you will deal with large activities and complex things, that you can make them small enough, simple enough, that single person can do it in some particular amount of time. And particularly for tasks, I hope that most of you already have some project management experience, and if not experience, then at least participation in projects. But usually task is something with, not usually, but task is always with start and end, and with some description for which you can tell, is this task done, maybe it's in progress or not done. And for example, different kind of tasks are do this, do that, so you always can get checkable output or post condition for this task to check that it is finished. And if you have more complicated task, for example, in practical exercise for this project, you will need to work on documentation of your imaginative system, then of course you need to do different kind of things. You need to establish communication channel between your team members. You need to establish a repository where you will store your documentation. Then you need to do different kind of regular or semi-regular meetings to exchange your ideas and information less formally and more freely and quicker than in written form, just using email or chat or whatever. Then you need to do some other things. If that would be a real project, sooner or later you need to think about development itself, about testing, validation, about deployment, about maintenance and other things. So these are different kind of activities and tasks within them. And then what is also important is that we may talk also about different kind of processes. Process is chain of different kind of activities. For example, one of process may be quality assurance process. And usually what happens is that processes are going concurrently in parallel during any non-trivial project. And inside this process there are usually different kind of activities and many tasks inside them, and they may go through reiterations or cycles about these activities inside them. And what is important is that in any non-trivial project these processes may be quite many. So if your team is small, then everything tends to be very linear, but as soon as your team gets bigger and you are working on more complicated projects, then these different kind of concurrent processes going on, number of these concurrent processes going on increases. And then particularly for processes, again, different kind of buzzwords and jargon may be used. Usually there are, for example, phase, and so task is already explained. Task is something with start and end, with checkable description that you can check is it done or not done. And usually task can be done by a single person, because when we'll talk more in details about management, if there is more than one responsible person for some task, then of course checking who is responsible for that and who will actually do this is much more murky and blurry, and you will probably not get intended results. But then there are different kind of phases and stages. Usually what I can tell about these different kind of reoccurring patterns is that you call something as a stage when you are planning on doing things in more linear approach. So you go only forward, you finish something, you start next, and such of these larger processes, these activities, may be called different kind of stages. So usually stages are going forward in time, like stage 1, stage 2, stage 3, etc. Or these particular names like analysis and collection requirements, development, etc. Phases usually are used if you are dealing with iterations. And I can't say that it is absolutely 100% correct in all the cases, but in most of cases it is following. So if you don't do iterations, so you go only forward and this is time, then you have stages. If you do in cycles, then you usually talk about phase. So you go through one iteration, phase 1, then you redo, it is phase 2, etc. But I will not be surprised if you will find out some exceptions about them. And then these patterns or reoccurring things in projects are, for example, this different kind of chain of activities, what you are doing, even though your methodology, your framework, how you are aggregating them, how you ignore some unimportant details and how you pay attention to important details are different. Is, for example, that you need to solve some kind of problem. You have some preconditions for this problem. You have some chain of activities or tasks to deal with this problem. Then you provide solution, and then you go next. And for these different kind of activities, there may be context or this environment to which this particular chain of activities or pattern is belonging to. And different kind of patterns may be, for example, customer communication, iterative design or iterative development, customer assessment, requirement expressions, etc. And then we will go in more details later, but there are different kind of international standards coming from different kind of organizations which describes these different kind of frameworks or models and patterns, and describes them that, for example, in this kind of situation, good approach or good pattern to apply would be working according to CMM, CMMI standard or framework or approach to do this project management in a such way. Particularly for information technologies, International Standards Organization is not so famous, but particularly for quality assurance and other, for example, there are different kind of standards and frameworks. For example, what is good practice to do quality assurance. And then there is IAC is organization of electrical engineers, which was extended to software engineers as well. So there are other standards coming from IAC as well, and we will go in more details about them later. And then what is important is that there are two very different approaches how to describe these things. One is prescriptive model, and another could be called reactive model. And where is difference? In prescriptive model, you get different kind of prescriptions, so you get guidelines about different kind of activities before time is actually has come, and you already have prescribed what to do in advance, and you do this only when time comes to actually do these different kind of activities. And these prescriptive models are a little bit older because of different reasons, more classical approach, but in general what you do is that you imagine future, you look into future, and you plan for many things in advance. But these reactive models, which here are called agile processes, but in more general, I think a better description for them is reactive. So different kind of events are coming into your management life, into these projects, and then you have different kind of descriptions how you need to react on these kind of events. So these are the newer school methodologies, which are not so much looking into future, but they are just describing what is the most efficient way to react on different events happening inside your project. But in general, both of these approaches have their strengths and weaknesses, so you should always know both. And one of these prescriptive models, which we will go into details later, is, for example, waterfall model. Why it's called waterfall model? Because here time flows from left to right, dependencies flow from top to bottom, and here you may imagine that all these large activities are something like buckets, and you fill them with water. And only when this activity is completely full with water, which means completely fulfilled, then this water goes over this higher bucket, and then you start filling up next bucket under it, and then next bucket under it, and so these dependency lines, how you go from activity to activity, is something like waterfall. And because of this graphical representation, so it's called waterfall model. And here are these most important large activities, also called stages, no surprise here. For example, requirements definition, software design, implementation and testing, integration and system testing, and then maintenance. And so what is good about waterfall? It is prescriptive model. If you use it, you know many things in advance. What is not so good is that you have to look very far into future, depending on where exactly this last stage of these activities will be. You actually need to look into future of several months and sometimes even into several years in advance into future, what of course is very hard because you also need to do different kind of decisions to decide about these stages to go forward. So, and that is bad thing. If it is implemented efficiently, it is very cheap because you don't redo anything, you only do what is required, what is agreed, etc. What is not so good because if some external influences come into this project, you actually do not have any prescriptive model how to behave on these changes. Some other problems what are, first, it is inflexible, so if you follow this particular model precisely, you never go back, you never respond to changes. So if you expect some changes, the expectations for these changes should already be put into model as expected changes, and so you expect them in required amount of time, and you do react on these changes in prescribed model. So you need to look into future, you need to make decisions early, and particularly for larger, more complicated projects, waterfall model actually deals only with so-called custom development or development of unique system which was never built before. But in larger projects, what actually is happening is that before first stage of waterfall model, you have preliminary stage just to go into this project, and then when this system is deployed, you actually, in any non-trivial large system, you need to think about decommissioning this system or migration of this system to newer system. So in real life, waterfall model do not describe all needed complexities of the life. Of course, neither model describes everything what is happening in life, but entering into this waterfall model and exiting out of this model is also very important part of different kind of activities in software maintenance and development. So you actually need to deal with them without guidelines coming from this particular framework or model. And V-shaped model, sometimes called V model, is evolution of waterfall model. So it has more number of stages, bigger number of stages. And difference here is that if for waterfall model, vertical axis didn't show anything particularly important except dependencies, in V model, vertical axis represents technological stack or technical complexities. And V model adds this aspect into consideration, that in these linear staged approaches, you usually start with very high level abstract things regarding to this project, and you usually end up with very high level abstract things. But then during this project, and in most of cases it is more or less symmetrical, when you go into them and go out, when you start thinking about requirements, architecture, detailed design and coding, you go deeper and deeper into technologies. So you need to decide more precisely what kind of technology you will be using, what kind of programming language, etc. And then when you have done coding, so it is implemented, you go up from this technological stack. You don't deal with particular programming language, particular framework so closely. You would start thinking about testing in unit test level, in integration test level, in systems level, and then in maintenance. And so this is evolution of a waterfall model, and it is more detailed, and it shows very easily what should be your scope and abstraction. For example, when you start doing testing, if you do unit tests, you need to go and look into detailed design. When you do integration testing, you need to look into architecture and high-level design. When you are doing system acceptance testing, you need to go into, look back into product requirements and system specification. And when you do production, operation and maintenance, you need to go back to high-level requirements and planning. So that helps to highlight your interest during testing much better than waterfall model. So that is good thing. And so it's easier to use than waterfall model, because model itself represents more details about software development projects. Again, these custom development projects, when you start building system from scratch, so you don't have any existing system before you were doing it. And because it pays so much attention on testing and traceability back to initial information, why it is important, why it needs to be tested, etc., it is very good for proper testing. And what is not so good, so in general, V model has the same weaknesses as waterfall model. You need to look into long future, you need to make decisions very early, and again, it is not so easy to handle different kind of changes. And also model do not show any risk analysis activities inside it, what other methodologies allow you to do and encourage you to do. But it is very good for collecting and using system requirements and testing them. And also it is quite good that if you already know in which kind of technology you will implement this system. And I do not know about today, but for example in older projects for NASA, like Apollo space program, space shuttle space program, and different kind of robotic missions to explore other planets as well, de facto standard how they developed software for all these space missions was V model. Because if you need to have high reliability of systems, if you need very good traceability and very well tested and very critical systems, then V model is still considered one of best approaches how you can be sure that the system is very well designed and very well tested for critical applications. And then there are different kind of approaches. For example, in real life you may do different kind of concurrent activities. For example, you do specification of the system, so you describe what it should do, then you develop it, then you validate it, which means checks that did you achieve required goal or not in this specification. Then you may go back to development or specification again, and then you redo it. And then you may, as output, maybe initial version of this specification. Then during these cycles you may get different kind of intermediate versions, and then when you hopefully go out of this loop, you get a final version. And I will stress this, of course, later when we go in more details about different kind of methodologies. But for iterative approaches, one of most critical tasks or activities you need to do is to check your progress, that you are actually not going here into infinite loop. Because otherwise you may just be chasing latest and greatest versions of programming languages, latest and greatest versions of programming frameworks, etc. But you actually will not implement anything more than in initial specification. You will be just busy beaver redoing all these things in different kind of technologies, but real output will not be different at all than from initial version. But bad thing for any incremental or iterative approach is that you need to check your progress against the previous phase or iteration, that you are doing progress. If you will not check for this, it's very easy to get busy going into infinite loop. But the better thing is that you don't need to look into so long, far away future. you don't need to make so big decisions earlier. You get better customer feedback because you can provide at least something. Customer use it and do different kind of improvements, etc. So a leading de facto standard for these iterative approaches is for different kind of applications for social networks. Important thing to remember is that at least till now, neither of social networks applications like Facebook, like Twitter, like LinkedIn and whatever, these are not business or critical applications. If there is something goes wrong, nothing very bad happens because it doesn't kill anybody, system do not completely crashes, not money is lost, etc., etc. So remember that if your application is not very critical and failures can be just handled somehow and dealt with them, then these incremental approaches are very good. Then you gradually just improve something. But if you need to develop very precise application where any error may be very critical, then these iterative approaches still may not be the best case how to deal with them. So, other things, what may be a problem is that for iterative approaches, measuring progress may be very hard, because you may have something working in many very early stages of the project, and then you can spend very big amount of time working on it, and still you do not have anything much different. You had system 3 months ago, you still have system very similar to what was 3 months ago, and if you do not have good tracking possibilities with different kind of approaches and tools, it's very hard to see your progress, what has happened during these many weeks, few months, how you improved your system during time. Another thing is that if you do everything with just small iterations, sometimes you get so-called technological debt, tehnoloģiskais parāds. That means system is working, but you are borrowing maintenance time from the future IT experts and maintainers, because system becomes more and more costly to maintain. So you add more and more craft and unneeded complexities on top of this system. And sometimes it is much better to do complete redesign and cleaning it up with these linear methodologies when you plan everything in advance, because such large changes in design are much cheaper and easier to do if you plan at least as much as possible, in theory, everything in advance. So that is also weaknesses of these iterative approaches, that it's something like evolutionary. Neither of evolutioned systems like our body and plants and animals, it is not best solution for something. It is just solution which works, because in this evolution approach you can't just make very radical changes. And then there are specific different kind of methodologies, because today many systems are actually not written from scratch. When you don't have anything, you actually have something before you started your project. So what is actually happening is that even if you are working on this particular unique customer project, you still may have some technologies before that project which you may reuse in this particular project, in this particular case, etc. So then again, this approach is a little bit different, because if for waterfall or V-model approach, you just start collecting, at least with their model, how they highlight these things, start with collection of requirements, you actually need to, for example, review what you already have in your previous system, how it can be reused, how it can be extended, redesigned to use in different situation. And then you actually, your initial stage is analysis of components and parts of existing system, which you may reuse in existing project. And then you do what is called gap analysis. Gaps means that there is gap between needed requirements and what your existing system can actually do. So you do this gap analysis and you do modification of these requirements, and only then you start working similarly to either V model or waterfall model or with some iterations, when you actually have decided how to change, extend and reuse this existing system. And so for this reuse-oriented software system, you may start with these requirements, for example, to do this gap analysis. So here you collect all requirements what you need to cover, then you do component analysis of existing system, and usually what happens is that it do not fit everything. So it may do something needed, but definitely in any non-trivial project, existing system doesn't do everything what is required in specification, because if that would be case, you actually don't need to develop anything. So you actually reuse everything as is, and it is not a development project at all. And then you do this analysis of your system, then you may modify these requirements, because you may need to decide that these requirements may need to be a little bit different, where influence of existing system is also considered. And then you do system design, develop it and validate it and implement it similarly to other methodologies. And then, as I already told you, besides this main stream of activities or main process of activities going on into your project, there may be different kind of streams or processes going on inside this project as a supporting processes. For example, your main task is collect requirements, create design, develop system, test it, deploy it, maintain it. But during that time you also need to collaborate with other involved parties, your customer, other involved companies like suppliers to you and your customers, where you provide different services to them. Then you need to, for example, this quality assurance and progress checking during entire project to check that you are working according to your decided plan, etc. So these supporting activities in general may be considered not as main activities, but they are still important, because without these additional activities it may happen that your main stream of activities or this main process of activities may not going well. And then, particularly for software specification, you may start into project with this feasibility study. So feasibility study is part of things I will explain in second part of this session. For example, when you create concept of your system, I call it just conceptions. For English speaking, it for some reason is not very widely used. But in general, what this means, you create concept of your entire system, why you should develop it, or why you should reuse it, or implement it, or use it, whatever, for different kind of needs and requirements. But before that, you need to do this feasibility study, which means you actually need to consider, can you afford it or not? Because in general, any system which is more powerful and rich in features also will be harder to develop, harder to test and implement and to maintain. So if you can't afford it, maybe your intentions should be to use and implement something different. Then particularly for requirements, important other activity is requirements elicitation. And elicitation means that you prune list of requirements as unneeded ones, because in many cases there may be that requirements are too high, specifications are too monstrous or serious, for example about uptime of the system, about availability of the system, about its speed and performance. Everybody can just require we need everything that it happens momentarily, that all the system is available 24 hours in a day, 7 days in a week, 12 months in a year or whatever. But of course, if that would be real requirement, always question is how you will make backups, how you will make upgrades of the system, etc. So then you elicitate or prune these requirements. You can check actually, do you need so high availability requirements? Do you need so high performance requirements, etc.? Then you specify these requirements and you may validate. So all of this is just, in general, just create requirements for the system. But if you will just write down these requirements without these other activities as well, then it may happen that your collection of these requirements will not be very good for this particular process. And here is one of models how it may be done. As you can see, it is not absolutely linear. It also shows some cycles here or reiterations. You do this feasibility study, which according to other models I will you explain would be development of this system concept. And then one of outcomes of system concept may be that you decide that you actually cannot afford any changes. And that's it. So you are not very satisfied with current situation, but if you do proper feasibility study, it may happen that actually changing something will not, at least with your budget, what you can afford, will not make things better. And usually that is what is happening when I'm working on my freelance projects. I'm never fully satisfied with existing systems. But when this feasibility study is done, and it shouldn't be always very formal, you just think about possibilities, etc. In many cases, outcome is just don't change anything, because what may happen after that is so costly that these benefits coming from all these changes may not be big enough to actually start doing this. But if you decide that changes are needed, then you do through these requirements and elicitation and analysis. You may show and create different kind of models. We will talk about these models in details later. Then you create this requirements specification, which specifies what system should do. Then you may validate these requirements, and here you can do different kind of iterations depending on your approach. Then you also may specify specific user and system requirements, and then you create this requirements document for particular system. And that is one of part of this session, and that was recurring patterns or similarities between different kind of project methodologies and project managements. And later we will go in more details about each particular approach. Do you have any questions or comments so far? In second part of this operation, I will tell you what is concept of operations. And concept of operations is standardized document, which is standardized by Institute of Electrical and Electronic Engineers, or IEEE, which in jargon usually is called IEEE. And this organization was Association for Electrical and Electronic Engineers, but later it was extended to cover also needs for software engineers. And then as a sub-part of this IEEE organization is Institute of Electrical and Electronics Engineers Standards Association. So that it's part of IEEE, which works on introducing and popularizing best practices in different kind of standards. And in this case, standard of IEEE is called Concept of Operations. Its number is 1362-1998, and this I believe is year when was made last update. Maybe there is newer version already created, I don't know. And full name for it is Guide for Information Technology, System Definition, Concepts of Operation, or CONOPS document. And similarly to other standardization organizations like ISO, unfortunately this standard is not free to use. You may get illegal copies, or you may get legal copies from your employer, but to read its content, to use it, you actually need to pay small royalty for it. Small for companies, not so small for private person, because it's usually in the range of few tens of dollars. So you have to buy it officially, and only then you can use. And this standard is also localized in Latvia by Latvijas Valsts Standards, which is Standardization Institute in Latvia, called LVS 75/1996. And here I believe again this shows year when it was last updated, and in Latvian it's called Sistēmas darbības koncepcijas apraksts. What is important here is that this document and approach how you create it and maintain it according to this standard is, for example, out of scope waterfall or V model, because you work on this document before you actually start any development at all. According to other studies, this may be part of so-called feasibility study, when you actually just try to understand what you have, what you need, can you afford what you need, and if you can't afford, then of course you decide that even though you are not happy, you just need to live with this. And when this concept of operation is used, there are two different roles when this document may be used. If you are author of idea, then this document may be used as a marketing pitch to convince involved parties that you have great idea, you need to get money to implement this idea. So in this case, you use concept of operations describe existing situation, to describe possible solution, and you do not have money, but you need to convince some investors or other involved parties who may give you money to convince that this is good idea to do these changes. Other thing is that the same structure of the document may be used in quite opposite role. You already have money, you have budget, let's say many hundred thousands, few millions or whatever, and you are seeking for ideas what is best possible way to spend this money. And this first approach usually is happening for private companies which are seeking for investors. Second approach is usually happening for public entities, and by public I means subsidized by taxpayers' money. So that means government, local government institutions which have some supplied budget for their activities. And when we will go in more details later, one of laws about project management is that if you have fixed budget, then what you usually do, you spend entire budget without any leftovers, and only question is how much you can do with this budget depending on how expensive things are or whatever. And because of that, focus and attention of some different parts may be different, because seeking for money, of course, is quite different activity than having money and seeking for ideas. But because everything here may be interchanged, there may be first you seek for money, then you got this money, then you may do next iteration or next phase of this project when you try to make more detailed concept of operations. And because of that, even though these roles are quite different, they are quite intervened together. So therefore the same approach is used, but of course focus is sometimes very different. And concept of operations is very user-oriented. Good concept of operations never show actual design and, God forbid, actual implementation. It is about users, about involved parties, about situations and possibilities, etc. So it should be as much technologically neutral as possible, and it should be as business-oriented or user-oriented as possible. And usually concept of operations is shown from viewpoint of one particular individual or organization, and this individual or organization usually is called business owner. So business owner is this responsible person or organization who is responsible for this particular business they want to investigate. And other involved parties may be different kind of partners. Partners may be two different ways. They may supply some services to you, or they may be customers to you. You are supplying some services to them. Then if you go in more details, they may talk about particular users who will actually use this system, because if business owner is organization, of course this software is not used by organizations. This software is used by persons inside this organization. And then it may touch also system developers. For example, they may be interested how exactly it should be developed, etc. And there may be other involved parties in this. And how do you apply it? In real life, concept of operations usually is created for large-scale projects, because for smaller projects this feasibility study or creation of concept of operations may be so trivial, so small, that you don't need to highlight this as separate stage of your project with separate tangible deliveries or outcome of this study, etc. So usually, what I have seen in my professional life, concept of operations is developed for systems which one of our teachers called megasystems, and he called these systems megasystems, which are very big, but I can give you more precise definition. Megasystem is system for which you spend money in terms of mega dollars or mega euros, and mega of course is C prefix. This means talk is about a million of something. And what are typical examples for megasystems? Solutions for large international companies like Fortune 500 companies, which have locations in several parts of the world, which have many thousands or even hundreds of thousands employers, etc., etc. Maybe solutions for different kind of government agencies. Their number of users may be small, but data are very big because they need to have large registers for all the companies, all the people in state, etc. Maybe also for local government systems, but not all local government systems are mega systems in terms of spend money as a mega dollars or mega euros. And partially, concept of operations may be used in small-scale projects as well. In your practical exercise, of course, you will start with this concept of operations, even though your delivery is not called in this way, because you will put concepts of operations inside this document, system requirements, system design, and other things. So you will package everything together, but initial part, or first part of your final delivery will actually be what we can standardize as concepts of operation part in your delivery. And what is the most important thing what you do in these concepts of operation stage or developing it? You do analysis of current situation and what are frustration, what is not so good about current situation, and then how can you improve this situation. And so where do you use it? For example, to see this gap between what these users actually needs for their operation and what the current solution actually provides. Of course, in some cases there may be no any current system at all, but because automation and informatization of different kind of business processes has going on for more than 20 years, in most of cases you already have some existing system which probably lacks some important needs, which do not cover some important needs for current users. Then you describe the characteristics of users and their needs. You describe them without requiring any technical knowledge beyond that what is required to the system. And during this stage of development of concepts of operation or conception, you may also do business process improvement, because especially if initially or currently organization doesn't have automated system and it is intended to implement automated system, not any process is easy to automate. So it may happen that if automated system is implemented in place where there was no automated system, some of process improvements and changes may be happening. Then you can modernize existing system. You may add new functionality of existing system. And role of concepts of operation. One of these things may be that if you have money and you are seeking for ideas, what is best possible way to spend this money, many organizations issue so-called requests for proposals, or RFPs, which is how it's called, for example, for internet standards. And then inside this request for proposal, you may already describe what current situation is and what intended situation is, and then proposals coming back from these requests are more concrete, more detailed proposals, but it may also be that your request is quite short, and then during the development of this concept of operation, additional analysis of existing situation is done to create better description of existing system. And this concept of operations should describe what are concerns on possible solution, what are design constraints, and what are different kind of ranges of acceptable solutions, because it may be that there may be different kind of approaches how to deal with current situation and how to improve it in future. And yeah, as I told you, in time frame, concepts of operation or feasibility study, which is documented as a concept of operation, is happening before waterfall or V-model projects. So these two methodologies or frameworks ignore this stage when you are not developing anything, you are just analyzing do you need to develop anything or change or whatever. And in many cases, this concept of operation is developed in several iterations. As I told you, typical iteration is following. You describe very rough concept of operation as a request for proposals. Then you get back proposals to these requests with more details. Then you may use these more detailed proposals to actually ensure that money you may or may not have in future you actually is guaranteed, etc. And then you update it even more. So during these stages, when you are seeking for money, ensuring that you will have this money, you are still working in technology neutral area. You are describing everything in these of the business terms, and in general you may have different kind of variations of these concepts of operations. Then when you have done with last iteration or just the final version of concepts of operations, you may use it to use as an input for requirement specification, test case specification, implementation plan, operator manual, user manual, design guide, etc. And depending on how many iterations or cycles and loops you have in this approach, you may have different kind of reviews. Even for these linear models, when you do not redo things, what you usually plan is several stages of development. So if you work with linear approach, time is here. So here you have final version of concepts of operation. You definitely need to have at least two different iterations for draft and approval, because you will never satisfy all involved parties in such a way that everybody will be happy with details, with concepts, etc. of your draft, and your draft will immediately become final. So if you plan it linearly, you need to plan at least one proposed draft and then updates, and then if you are lucky, you finish it with final versions. But much more realistic case is that you already plan for approximately 3 stages of these iterations, because there may be objections and adjustments when you do some changes for initial draft, and you change something, and then there may be objections to these changes, then you update these changes, and hopefully objections to the changes of changes will be even less, and then more or less everybody is either very happy or not very unhappy, and then you make, or if you just say you go into loops, and number of loops is whatever until you are done. So that's about these things, that you never will create a final version of this conception just with one iteration. And as more complicated system is, as more involved parties are into this system, as more iterations you may need. And then all these involved parties need to agree about this conception. Of course, primary owner who has final say, is it okay or not okay, is this business owner who is sometimes it is initiator, actually in most cases it is also initiator of this study on this investigation, then different kind of partners, and then if it is managed as a dedicated project, there may be project owner for this particular project if you make this feasibility study as a separate project in your organization. Then there may be system owner or manager, which may be different partner, because business may be very big. For example, business may be large company like Microsoft, SAP or Amazon. Then of course project owner and systems owner will be some department of the system, because in most of cases you never will describe all the systems for these large organizations in one single concept. Then there may be system developer already involved. If, for example, you have long-term contracts with different kind of vendors and different kind of infrastructure providers, because any system may need to live somewhere. You may have your own infrastructure, you may lease some infrastructure for some suppliers and vendors, etc. And most important thing is that from political philosophy perspective, of course, responsible is this organization or business owner. In practical terms, it means that the main responsibility is this project manager or owner who is working on developing these concepts of operations. And what is very important is that depending on structure of organization, these who are doing these feasibility studies, interviews and reports and studies of data, etc., may be done either in-house. For example, you have your IT department who is working on development of these specialized systems. You do this inside your own organization in particular department, but it may be outsourced in such ways that your primary business is logistics or medicine or finances or whatever, and you buy contractors who are developing this conception for you. And then if you are doing as a contractor, then of course main responsible organization is still business owner, but your responsibility is just to be sure that you are properly making this study, you are properly documenting what you have found during this study, and that description of current situation is done properly, that possible solutions are proposed properly, etc., etc. And now about particular details. So what is content? In large parts, these are three parts of content for this document. First, existing system, manual or automated, what a business owner currently has, what problems do they have, what their frustrations are, and then, because of these frustrations of missing things, etc., you need to provide this reason for changes, because it may happen, as I told you already, if you look in more details, neither system is ideal. There always may be some improvements and changes in the system, but you need to check, is this good reason for changes or not. And then you describe proposed system in high-level business requirements, not in terms of technologies, but how this current frustration of this business owner may be minimized with newly developed changed system. And here is overview of this concept of operation structure. So here are introduction parts like revision chart, because as I told you, I will be surprised if you make conception just with one draft and this draft becomes final one. Then list of, as any formal document, list of figures, list of tables, introduction, referenced documents, for example, what you have used as a source for different kind of information and data, current system or situation, justification and description of changes. And this is important because if you can't justify changes, then changes are not needed. Then proposed system or situation and detailed analysis of proposed system. And in this introduction, what is very important is that you provide identifying information for existing and proposed systems and situations, because in any non-trivial project, talk may be about different parts of businesses, different parts of organizations, etc., etc. So that means scope, or how large area of business owners' activities you are analyzing and investigating is very important part, because for large organizations it definitely will happen that you will not analyze everything, you will analyze only some part of everything what this business owner or your customer, if you are doing this analysis as a contractor, is doing. Then because of that you may show different kind of relationships to other relevant documents, for example, other concepts which have different scope, for example, which are describing other activities of business owner, what is intended audience, what is expected evolution of the document, for example, how new iterations or versions are done. Then, of course, if you are working with some sensitive area like medicine, like finances, etc., you also need to state exactly what are security and privacy requirements for these documents. Not all concepts of operations may be publicly available. For example, if it involves something about military needs, about medicine, finance, etc., it may be with limited availability to different kind of persons. So, reference documents, you just refer to everything what needs to be referenced as additional sources of information. In current situation, you do investigation of what business owner has, how it works, and what are these problems. Then, for background, you say, for example, what is related information, missions, goals, objectives for this business owner, different kind of policies and constraints. For example, what one of policy may be regarding to, for example, for international companies, they have policies that they don't work in particular areas of the world. Another policy may be that they choose not to support particular kind of businesses in their particular activities, and other different constraints which maybe add different kind of limits of current system and other things. So in description of this current situation, in most of cases such kind of documents are mostly written as a text, but you may also show different kind of graphical models to show relations. You may show tables and charts, you may show different kind of diagrams and pictures which may be used as a easier to understand information than just written text. And then in more complicated situations you need to describe modes of operation. Modes of operation are usual days or abnormal days. For example, business as usual is one mode of operation. You start using system at 9 a.m., finish using it 5 p.m., but in some abnormal situations you need to use it also during night, during weekends. Some of abnormal modes of operation may be, in most of cases, you rely on connection to the internet. But if particular business related with medicine, related with logistics is very important that it still works without connection to the internet, you have these abnormal modes. For example, file over situations, for example, you need to describe how this happens if there is no network connection, like create local notes on local computer or whatever, and then fill up them later when you have connection to the internet again. For example, modes of operation for different kind of emergency services. They may have normal days, how they work, and then they may have earthquake that is not happening every day, so they need to prioritize different kind of requests because otherwise they do not have. Similarly, for example, for medicine, if you have this COVID wave of hospitalized patients, then your mode of operation is different than if you do not have many patients with this particular illness. So in more simpler businesses, they may have only one mode of operation, so they just have everyday gray day approach. But for more trickier business, there may be these different kind of modes that they switch from everyday mode to emergency mode or failover mode or whatever. Then you need to describe what are all the users and stakeholders. Stakeholders are involved parties which have their skin or resources in the game. That means vendors and suppliers, these who supply some services and these who use some service of this business owner. And you need to describe them in detailed enough ways that you know how they are actually currently working and how these possible changes may affect these users and involved stakeholders. Especially if you introduce new system, most important thing is how business process will be changing from different kind of manual operations to more automated operations, or if you have this too centralized internetized system and actually your business owner is frustrated that everything is working very slowly when they do not have connection to the central part of the system, you actually may need to decentralize this system to make it more local with some replication going in background, because otherwise this business is just happening too slow because network connection is not reliable or latency is too big, so it is too slow. Then you may need to describe different kind of support environment. That means hardware, software, supporting organizations, facilities, different kind of maintenance approaches, etc., etc. And then important part is justification and description of the changes. So you have described current situation as it is, but in this part you describe what from this as it is actually bad or maybe improved. So you describe different kind of shortcomings, missing features, missing functionality, missing performance, missing whatever, and you summarize them, provide all these deficiencies of current situation, and you justify it, or you defend your position that it is worth doing some changes to change current situation to the better. And then you describe these changes, how you can change existing situation to the better. First you write some short summary, and then you go in more details. For example, what are priorities? For example, in many complicated systems there may be different kind of subsystems, and you may not be able to afford change everything. Then you write priorities, how you start changing, and then what changes are just nice to have. Then again, because of these feasibility studies, what business owner can afford, you may describe changes considered but not included. For example, it would be nice to have this additional model for the system. It would be nice to change this to that, but then you describe why these changes are out of scope of this current concept, because in most of cases it is just lack of time and lack of money. And then you describe situation for proposed system, and here detailed paragraphs are similar to current situation. You describe different kind of objectives and scope, background, which means how this concept of new system lives into its environment, because usually there are always external dependencies and links with existing solution, new solution with something else. So what are goals and missions to reach with these changes? What are my business drivers? What are motivations? Then again you describe policies and constraints. Policies are things, for example, how according to the goals of organization you decide self-imposed constraints that they for some reasons will not use this, will not do that, or some other constraints what they cannot afford or they do not want to afford, and other things. And then you describe in more detail this new system, how it will work, how many parts it will have, like interfaces, capabilities, functions, charts, costs of operations, risks of factors, etc. How it will be improved, for example, speed, throughput, amount of data, frequency, different kind of quality attributes like higher availability, better correctness, efficiency, expandability, flexibility, safety, privacy, security, blah blah blah. Then again, for easier businesses, they usually work in one single mode of operations. For unusual businesses, they may have these different kind of modes of operation, like normal mode, emergency mode, and failover mode, and recovery mode, and different kind of things. So you, in many cases, in these unusual modes, you need to pay more attention than for usual business mode, because usual business mode is usually very well analyzed and very well known. But these unusual modes, sometimes you just, if you do not do proper analysis, you may just skip them because you didn't have enough information and data, that in some cases this business is actually working completely differently. Then again you describe all these anticipated users and stakeholders, how they will be doing this, how they are affected, etc. Then you write proposed support environment, like supporting organizations, facilities, equipment, hardware, software, maintenance, distribution, supply methods, etc. And these operational scenarios, how you describe, for example, typical use cases, how they work, how this is happening, etc. This part of operational scenarios may be input for more detailed cases for requirement specification, for test case specification, for user manual, maybe for system design as well. Then you describe these operational scenarios or use cases or studies. Then you make summary of impacts. Impacts are following. For example, if you make business more efficient, actually your business owner may fire some amount of personnel, or some amount of staff may be retrained because previous work positions will not be available anymore, but some other work positions will be available during this system. Then, of course, you need to analyze, will it be possible to retrain everybody from one business scenario to another. For example, there are people who still hate or don't like to work with computer, and so all these possible changes on personnel, on staff, on other stakeholders like suppliers, providers should be analyzed, and all these impacts. For impacts, you need to analyze, for example, how interfaces will change, how procedures will be changed, how operational budget will be changed. Hopefully you will be able to prove that operational budget will be smaller, that different kind of risks will be smaller, and other things. Organizational impacts, what I told already, you may need to reorganize this organization, because this current organization, this new system will not be working efficiently. You need to retrain users, you may need to hire new employees, you may need to fire old employees, because skills are changing if you can't retrain them. Any other impacts on involved parties. And here it is very important that it's very easy, especially if you are in sales pitch mode. Somebody has money and you want to be better bidder for this who has money, to use this approach to implement this system to be better than other possible providers, suppliers, or whatever. But here, and then your normal mode of operation is something like this. You write everything what is bad about current situation, and you write everything what is good about new situation for this new system, because then, of course, you have better justification, easier life to prove in quotes, that this new system will be better. But anytime you have at least experience for writing one concept of operation for at least one project, remember that if you analyze projects in terms of these three most important metrics, on time, on budget, on required quality, most of IT projects fail. That's just fact. And if you will have enough projects, most of your projects will fail as well. And then, especially in large expensive projects, especially in USA, where this business of suing somebody is very popular, remember that if you will be responsible for some of these failed projects, your business owner, which probably will be your customer to whom you implement your new system, will try to sue you that you didn't do enough high quality analysis about current situation, about risks involved in this new system, about its constraints, about its different modes of operation, etc. So remember, when you are working on concepts phase, you always need to remember that probability that you will fail is very high. You may hope for best, but hope is not good plan. And therefore, to be safe that you will not be sued from your customer, that it was your responsibility and your fault that this system was not implemented on time, on budget, and on required quality and features, you actually need to describe, I think, in more details what are constraints, what are risks, and what are not so good things about this new situation than these good things. Of course, it may happen that in this case you will not win this particular bid. But we will talk in more details later. There is another project approach, which is like your policy is, because of different reasons, just to win this particular bid, this particular project. But then remember that that was your policy, that you may oversell yourself and your solution, and it may actually fail with bigger probabilities than for other projects, because you described current situation as too bad, and you described this new system as too good. So remember about this, that it is completely wrong just to describe everything what is bad about current situation and everything what is good about new situation. You have to describe everything neutrally. There is always something good and bad about current situation. There is always something good and bad about new situation. And definitely, to get into new situation, your customer or whatever who pays for all these activities, they will just spend some money and effort on it. So, and if they are spending this money for nothing, then of course you may get a lot of trouble. So, therefore, my recommendation is that if you want to make your concept of operations future-proof, always describe it in neutral terms, because you never know how this concept of operations may be used against you, not for you. Of course, marketing and other things and winning for any price is different kind of approach. But if you want to describe concept of operations properly, it should be neutral. Always remember, new system is not only good. New system will cost something. It may affect personnel. Somebody may be hired. Somebody may be fired. Different kind of other influences and dependencies, etc., etc. So always remember that all these things should be described neutrally, otherwise you may get into big trouble at the later stage of project when you are just following this concept. So therefore remember, all these impacts should be described as far as you can, because this is your exit strategy if something will fail inside this project and in later stages, and failing is very high probability. So that's about this analysis of proposed system. So you provide some summary about these improvements. You describe disadvantages and limitations. So here you should be honest. What are these disadvantages and limitations of new situation? What are different kind of alternatives and trade-offs? If you do study good enough, and you can do study good enough if you can spend enough effort on it, then you will see that there is just, in any non-trivial case, there is no silver bullet solution. There are just different kind of benefits and drawbacks, solutions on different kind of situations. So you need to neutrally describe, for example, this situation or this approach is better in this area, but it will cost more. This is cheaper, but it has these limits, etc. So a few alternatives are always good. Approximately 2-3 different alternatives is good enough. if you are going into many alternatives, then probably this means you have not done your priority analysis, risk analysis good enough, because then it means you do not have good preferences for what is best solution for particular problem. And then you may have different kind of appendixes for it about additional data and which data this analysis is based. And here again it is very important, because if somebody is giving data to you and these data are wrong, for example about saving costs, about improved performance, improved time, etc., this is important that if you also rely on somebody else on your studies and investigations, that you again have this failover and exit strategy, that if something goes wrong, then you are not the last person in queue who will get punished. Then glossary about terms, and that's it about concept of operations. So I can leave this part here about overall structure. Do you have any questions or comments so far?